Hi everybody, this is your first homework assignment. I'm giving you every detailed steps here so that you can do your homework and get familiar with each step. Okay, simulation tools like this can be very complicated. So one thing that I'm not going to go through is I'm not going to go through every single um, icons here. There are so many, we don't need everything. So let's just focus on a couple of icons that we will need today. Now make sure you have new project. Okay, the first thing that we need to do, actually before we go on to the jump into the project, what we are going to do is we're going to do exactly the same thing that we have done in the class. Basically, we're going to build a plane wave here, this icon, and then we're going to have a certain frequency sine wave coming into that plane wave. Okay, and see, you just want to make sure that everything um, runs okay. Now, the first thing that we need to do here again is creating the geometry. Again, we're going to use this plane wave. Click on plane wave, and you will see something like this, the new plane wave source coming up. Now, if you move your mouse cursor to the geometry area, you will see everything, the number is changing as mouse is changing. Okay, and, but we're not gonna click anything here at this point. So what I want you to do is move on to here. What I want to make 2 meter by 2 meter by 2 meter box. So meaning if you have 1,000 and 1,000 or 1,000 millimeter. Now if you have minus 1,000 and that's 1,000 and minus 1,000. Okay, now click apply, but before we click apply, let's try this. If you move your mouse cursor to the area again, it is basically changing the location, and as you can see the number has been changed. So you don't want to stay this mouse outside. Let's go back to minus 1,000, minus 1,000, minus 1,000. That's the tricky part. I don't know why they did that way, but that's how they build the software. So you don't have any choice. Okay, just make sure that you stay your mouse inside of this new dialog. Click apply. Now click this. As you can see, there is our geometry. Okay, this is nothing but a plane wave, a box. So everything, the simulator is going to calculate values only inside of this box. Okay, now go to EM simulation tool, and here we are going to apply all the necessary parameters. Go to setting and harmonic broadband. In this case, I'm going to have a harmonic. Now try 0.5 gigahertz. Okay, you saw that wavelength has been changed. Now again, simulation time, I want to have enough time here. So I click 100 and make sure this one is selected. Go to solid region, click on background, and you will see the parameters of the background, which is the air. Make sure you have one as permittivity and permeability. Just leave everything as it is. Source, just have to make sure that you have enough sine wave coming in. Okay, so there are hundreds of sine waves. Now we're not going to use lumped elements, so skip this part. Go to sensor, make sure that we have overall field already generated. Now if you look at the radar cross section, we don't want to have anything that we don't need. Okay, if you save this, it will just occupy more hard drive space. So basically, I just want remove this because we are not interested in radar cross section. Boundaries. Just leave it as ABC, 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 ABC. That is, we are basically mimicking the free space here. Okay, grid. Go to grid. Okay, now it is automatically calculated in the size of um, the small digitization, the small box, the Lego, is determined by itself automatically. Okay, now go to voxel, right click, and click make voxels. And you see it says I'm going to save it. So let's um, save the data. I'm going to say plain way homework 1. Okay, now you're not done. We now are ready to run simulation. Go to here and press run simulation. And just keep looking at this part. It's a little bit bigger simulation than before, so it takes a little bit more time to compute. Now the status bar is now going up, and it is now running properly. Okay, 68% done. Okay, the simulation is now done. Now what you need to do to look at this wizard is click on wizard. Click on folder field, and what I'm interested in is looking is the electric field. So go to electric field, the EXYZF0, and here right click on it and look at click on slice field view and say next, say next. Now you are looking at the electric field. Okay, I'm going to just have y axis 0 plane. By just clicking, by scrolling this, you can actually see different planes. What I'm going to do is removing this dv. I want to look at the linear. Okay, and that looks like a sine wave. Make sure, there is no minus sign. This is magnitude of the electric field. So if you see two signs, two hot points, hot lines like this, that's sine plus and minus sign. Okay. Now click animate, and this is how the electric field is traveling inside this box. Now stop animate. Now let's look at make 2D chart. There we go. Let's make it a little bit more square looking. And your assignment, the result that I'm looking for is go to export dialog. You can probably export as JPEG. Go to file and save as whatever wherever you want. I'll just say plain way. And you make sure you press export. Now this is what you just have generated, and I want print out of this graph. Alright, that's it. Thank you. Hi everyone, this is homework number 3. There are two problems in homework number 3. One is the lossless case, and the second part of the homework is the lossy case. I am going to explain this homework based on the lossy case. Okay, first of all, I was able to model this geometry. This geometry is the coaxial cable. As you can see, this one is the outer conductor. This is the inner conductor here. And in between the outer and inner conductor, there is a dielectric material. Basically, it's plastic, low loss plastic in between. Now, one thing that I want to show you is this port. Okay, this is the port for this specific application. We are not going to use the edge source that we used to use. We are going to use what is called the waveguide source. Okay, at this point, you don't have to know what this is. Now, let me go to here again and click this one. This is the port sensor at this point right here, and I will I'll tell you how to make it after several classes later. We'll probably use this sensor for antenna. So now this is the sensor that actually measures the current and voltage just at this point. Okay, you don't have to do anything about it. Just use it. Just for now, you just have to use it. Okay, go to setting, 1 gigahertz, 100 periods. Solid region, you actually have to make sure this dielectric, and make sure the permittivity is 2. The default value here is 1, but I calculated this coaxial cable based on permittivity of 2 material. So put it here 2. Inner diameter, outer diameter, make sure these are PEC, perfect electric conductor. You can select PEC from here, and same with the outer conductor. Source, again, make sure that we have 100 sine waves here. And don't worry about lumped element, go to sensor, and here you just have to deactivate each of these. You don't have to know what these are at this point. So just make sure that you have overall field and port sensor activated. Boundary, don't worry about it. Just click here and click here. Go to right click and then make voxels, and this will make the voxel. And make sure that you actually have this voxel generated. Okay, as you can see, there is smaller mesh at the center, at the center conductor, and larger mesh at the outer conductor. Okay, now if you go to widget, there's nothing, of course, because we didn't run the simulation. Now you need to run the simulation.